In this video, we'll learn about the Cahn, Ingold, Prelog rules for assigning RNS stereochemistry to our stereocenters. Before we start, we remember that our stereocenters are atoms that contain 4 different groups. So we're usually looking at a carbon that contains 4 different groups attached to it. That gives it chirality. So that'd be our chiral center. And there's rules so we can determine which handedness the chiral center has. And the rules for figuring out our chiral center are we're first going to look at the atomic number to prioritize our groups. So we want to come up with a ranking of which group is the most important to the least important. Which group has the highest priority to the lowest priority. First, we're going to rank the groups by using their atomic numbers. Then, after we've ranked our groups, we're going to arrange the molecules so the lowest priority is facing backwards. That would be the dash if we draw in a tetrahedral configuration. Then we're going to count the group priorities 1, 2, 3 to determine the handedness. The direction of the first, second, and third priority groups, if they go clockwise or counterclockwise. Clockwise gives us an R configuration. Counterclockwise gives us an S configuration. And one thing before you start, a handheld model is very helpful to be able to visualize this when you're first starting out. Or if you're extremely good at visualizing in 3 dimensions in your head, you may not need the model. But I highly recommend having a model when you first start this. So step 1, we want to assign the priorities. We want to figure out which one is the highest, we'll number that number 1, and which one is the lowest, we'll number that number 4. And so when we're assigning the relative priorities, first step is the atom with the higher atomic weight or number is a higher priority. So for example, if we had a carbon, the fluorine, the chlorine, a bromine, and a hydrogen. Looking at your periodic table, or you might know this already, which one is the higher number? Bromine's the highest. It's the heaviest atom. Chlorine's the next. Fluorine. And then hydrogen is our lowest priority. So we can number our priorities as such. And then if we want to connect our priorities, I'd have 1 to 2 to 3. And I would use the way the arrows are going around the circle there to determine if it's going to be R or S. So remember, if it's clockwise, it's R. If it's counterclockwise, it's S. So this one would be S. It gives me an S configuration for the handedness of this chiral center. So let's try another one. Say we have our carbon, fluorine, a methyl group, a deuterium, and a hydrogen. When we're trying to figure out the priorities for these groups, remember we're looking at the atomic weight or the atomic number. So hopefully you all know fluorine is our heaviest one. Carbon is next. And then we're kind of stuck here between hydrogen and deuterium. They're both isotopes of the hydrogen atom. Remember, regular hydrogen is 1 proton, 1 electron. A deuterium is an isotope of that. It's 1 proton, 1 neutron, and 1 electron. So that means hydrogen here has an atomic weight of 1. Deuterium has an atomic weight of 2. Because deuterium is a heavier atom, it weighs more, it gets the higher priority. So then when we connect the priorities together, they end up going in the opposite direction. So this would give us an R configuration because they're going clockwise. It's just like if you look at the hands of a clock, they go around in a circle like that. Our priorities are going around the circle like that. So step 1A, not too bad. Just look at the math. Which one weighs more? That gets the higher priority. And if you need to, have your periodic table next to you so you can just look at it really quick to figure it out. Step 1B, if they have the same atomic number and weight, use the next atom along the chain to determine which one is the higher priority. So again, if we have our carbon, now let's say we still have our fluorine and our hydrogen, but now I have a CH3 and a CH2, CH3. So we have a methyl group and an ethyl group. So when we're looking at figuring out priorities, fluorine, still the heaviest atom. It gets number 1. Now we're going between ethyl and methyl. They're both carbons. So they both have the same atomic mass. I didn't indicate there's any sort of isotope here. They both are regular carbon-12 atom. So technically they have the same priority. If we follow just step 1A, now we're looking at 1B. We go to the next one along the chain. So let's think about what is attached to the carbons. With our methyl group, our methyl group has 1, 2, 3 hydrogens attached to it. This carbon here, it has 1, 2 hydrogens, and then its fourth bond belongs to a carbon. So since that fourth bond belongs to a carbon, if we look at the groups that are attached to it, with my methyl group, I have 1, 2, 3 hydrogens. With my ethyl group, I have 1, 2 hydrogens, and then a heavier atom, I have carbon. So since the ethyl group is attached to another carbon atom, it gets the higher priority because it's attached to a heavier atom. So that means this is number 2, and this is number 3. Our lone hydrogen is still number 4. So this one, again, gives us an R configuration. So let's try one more. Let's say we have a carbon. It's attached to a methyl, a propyl, and an isopropyl. And a hydrogen. So when we're looking at this, we know right away the hydrogen is going to be our lowest priority. Let's get that one out of the way. Now we're going to look at the other 3. I have a methyl, a propyl, and an isopropyl. So my methyl has hydrogen, hydrogen, hydrogen on it. The propyl has hydrogen, hydrogen, carbon. That one's going to be higher than the methyl. And then our isopropyl, you can see has hydrogen, carbon, carbon. Since the isopropyl has 2 carbons and the propyl just has 1 carbon, this one is attached to more heavier atoms. So that means it gets the higher priority. So it gets our first priority, propyl gets the second, methyl gets the third. So you can see we're going in an S configuration. And if you ever come to the spot where there's a tie, you'll look at the next carbon out. So let's look at an example of that real quick. Here, let's say we have a carbon, methyl, propyl. So now on this side, ethyl group, and our hydrogen. So that means our hydrogen is number 4. Again, if we look at what's attached to it, methyl has hydrogen, hydrogen, hydrogen. Hopefully we're all getting good with that. Propyl, I can see has hydrogen, hydrogen, carbon. Ethyl, remember we're looking at this carbon here. That's still hydrogen, hydrogen, carbon. Looks like we have a tie. They're both attached to the same types of atoms. So they're both equal to each other. Which means now we have to go to the next carbon on the chain, the next atom on the chain. So that means we're going to look at this one. We're going to look at this CH2 and this CH3. So that CH2, that's attached to the hydrogen, hydrogen, carbon. This CH3, that's attached to hydrogen, hydrogen, hydrogen. So now when we're looking at the second atom on the chain for both of them, the ethyl group is all hydrogens. The propyl group is 2 hydrogens and a carbon. So it has the heavier atom. So that means our propyl group becomes our first priority, our ethyl becomes our second, and our methyl is the third. So that will give us an R configuration. And sometimes you need to go further out on the chain. It doesn't matter how far you go out, eventually you'll find a difference. So you may just have to go to the second atom out like we did here, or you might have to go to the third or fourth. It doesn't matter. Just keep going out till you find the difference. And always look at what they're connected to. So we've looked at step 1A, look at the atomic weights. 1B, look at what the atoms are attached to if they are the same atomic weight. 1C. So far, we've only looked at single bonds. When we have a double or triple bond, we treat it as if it's bonded to a separate atom. And let's go into a couple examples of what this means. So let's say we have our carbon. Now it's going to be attached to a bunch of different stuff. Oxygen, carboxylic acid group, aldehyde group, carboxylic acid, and a hydrogen. So when we're looking at our groups here, we can think about which atoms they're attached to. Here, this one's attached to an oxygen, carbon, carbon, hydrogen. Hydrogen, you've probably guessed by now, it's going to be the lowest priority. oxygen is heavier than a carbon. So that's going to be our first. And then we're looking at aldehyde, carboxylic acid. Here, our aldehyde is double bonded to an oxygen and single bonded to a hydrogen. Here, our carbon is double bonded to an oxygen and bonded to another oxygen. So when we're trying to figure out the bonds, in case we didn't know, I can look at the carbon here. This carbon has 2 bonds to oxygen. So I'll count its groups as oxygen, oxygen. And then I have a hydrogen here. So even though there's 1 oxygen here, there's still 2 bonds to it. That's why I write 2 oxygens. And if there's a triple bond, I would write 3 oxygens. So then if we look at this carbon here, I have bond to an oxygen, second bond to an oxygen, third bond to an oxygen. So that'd be oxygen, oxygen, oxygen. We always want to have those 3 different groups to look at to figure out the priority. So even though it's just 1 atom here, there's still 2 bonds. That's why I write 2 oxygens. Just like here, 2 bonds, 2 oxygens. So if we look at it, this has 3 oxygens, and this has 2 oxygens and a hydrogen. So the carboxylic acid gets the higher priority over the aldehyde. Which means we have an S configuration. So let's try another one. Here we have our carbon. Let's add something different. Let's throw in an amine. Nitrile. Another amine. And a methyl. See, sometimes we don't have hydrogen after all. So now we got to figure out our priority for our groups. Well, I have carbon, carbon, nitrogen, carbon. Nitrogen wins. It's the heavier one. So now we have carbon, carbon, carbon. We got to figure out what's what. Here, this carbon has 3 hydrogens on it. This carbon has 2 hydrogens and a nitrogen. This carbon here, if we remember our nitrile functional group, remember it's a triple bond. 1, 2, 3. So that means it has 3 bonds to nitrogen. So even though there's 1 atom, I count it 3 times because there's 3 bonds to it. So now if we look at this, methyl, that's our lowest priority. Our methylamine here, that's our second to lowest. And our nitrile is our second priority. Which means now we're going in an R configuration. So hopefully you guys can now come up with the priorities, put them in order for the priorities, at least number them. And as you see so far, I've always been drawing it with the fourth priority, the lowest priority, in the back. That's the configuration you need it at when you're trying to figure out if it's R or S. If that fourth priority is not in the back, you can't figure out R and S correctly. So here comes the part to be able to visualize it 3D and where your model will come in handy. Sometimes the fourth priority is not drawn in the back. Let's say we start with our chiral center we have here. First, let's assign our priorities. 1, 2, 3, 4. So here, when we're looking at the priorities, we can see our highest priority one is pointed backwards, and our lowest priority one is on the side. When we want to figure out R and S configuration, we want that lowest priority to be the dash. So we're going to have to rotate. And it doesn't really matter how you rotate. You should end up with the same compound. Let's say, so if you have your model kit in front of you, grab the top atom. So we're going to grab the fluorine here, hold it in place, and then take the 3 bottom atoms and turn them kind of one click. So what I mean by that is the hydrogen will move over here, the chlorine will move up forward, and the methyl group will move back there. So turn everything kind of one click. So here, if we hold the fluorine and we do our rotation, we end up with our compound that looks like this. So now if we renumber our assignments, we see when we connect it together, I got 1, 2, 3. So I'm going counterclockwise, which means S. And I'm sure you're thinking to yourself, but if I just looked at the other one, it was the same thing. It looks like it's S. That's true in this case, but it's not always true. So let's do that again. Let's hold the fluorine and do one more rotation. So we're going to rotate the chlorine over, the methyl group back, and the hydrogen in front. So again, you do another click. And when you do that, we have this configuration. So now if we look at the priorities, I have 1, 2, 3, 4. So in this case, our fourth priority is coming forward. And when we connect them, 1, 2, 3, it actually starts to go in the opposite direction. So it looks like it's R when it's really not. So when we have our lowest priority pointing backwards, that's when we can really tell the configuration. If the lowest priority is pointing forwards towards you, it actually looks like the opposite configuration. So that's one thing to keep in mind. If that lowest priority is coming forward towards you, you're actually looking at it from the back side. You're looking at it from the opposite side, which means you get the opposite looking configuration. But if you tried to tell me this was an R configuration, that would be incorrect. It just looks like it's R. It's not actually an R configuration. It's actually S. And so as I said, it doesn't matter which group you hold. just as long as you can turn that first and that fourth group to try and get them in the correct configuration, to try and get them in the correct spots. So here, this would be what happens if we hold the fluorine in place and turn the 3 bottom ones. Now, let's try and hold the methyl and then turn these 3. So what that means is I'm going to take that hydrogen, move it to the chlorine spot, take that chlorine, move it to the fluorines, and take the fluorine and move it to the hydrogen. So here I have my carbon. I kept my methyl in the same spot. That hydrogen moved back, chlorine moved up, and fluorine moved down a little. So when we number our priorities, 1, 2, 3, 4, you can see it's still going in that S configuration. It still looks like it's S. So it doesn't matter which group you hold when you're doing your turns, just as long as you can get that 4th priority facing to the back. And you can see it also doesn't really matter where the other 3 are, just as long as that 4th priority is in the back. If you accidentally turn it and that 4th priority is in the front, whatever you come up with, it's really the opposite. So now that we've seen how to assign our priorities, how to assign R and S, let's practice a couple of them. First, we're going to start with those tetrahedral carbons. So I'm going to give you a couple of them. I want you to write it down. Try and figure out the R and S. You may need to rotate, you may not. And then see how well you do. So here we have our first one. Our second. And our third problem. Try and figure out the RNS configurations. Pause the video, see how well you do. So now that you have your answers, let's see how they compare. This first one, we have 1, 2, 3, 4. You should have gotten an R configuration. For our second one, remember, pH is a phenyl group. That's your aromatic ring. And that should also give you an R configuration. And then our last one, hey, look, another R configuration. So did you get all 3? Let's try another one. Something a little trickier, a little harder, where you can't necessarily rotate it that easily. So here, we're in a ring. And remember I told you if you had a ring with more than 2 substituents, you had to use different rules for assigning the configuration. Here's those rules, R and S. Remember, if you just have 2, you can use cis and trans. If you have more than 2, you have to use R and S. So I want you to look at this, draw it, try to figure out the RNS configurations. Pause the video and then look at the answer after you're done. Okay, let's first add in our hydrogens. Just to make it easier so you can see all 4 groups. So now when we're trying to assign our priorities. Here, my oxygen is 1, my hydrogen is 4. Easy peasy, I can do that. Then I need to look at the next one. Here I have a CH2, here I have a CH2. They're both the same, which means we look next on the chain. Here, I have a CH with another CC. So it has the CHC. Here, I have CNH. CNH, which means this carbon, this group has a higher priority over this one. So that would be 2 and 3. So that means we have an R configuration. Now, we're going to do the same thing with this carbon. Here I have 1, 4. Again, CH2, CH2, CO. Okay, that's higher than CC. So that means this gets number 2, and this one gets number 3. So you can see now we're going in the S configuration. And now when we look at our last one here, I have a CH3, CH2, CH2. The CH2s get the higher priority over the CH3. So now we look next. Here's a C, O. Here's a C with an N. O is a higher atomic weight than N. So this side actually gets 1. This one gets 2. My methyl gets 3, and the hydrogen gets 4. So it looks like it's going in the R configuration. But remember, that hydrogen is pointing forward. If our lowest priority is pointing forward, it actually is the opposite of what it looks like. Since I can't take this molecule and easily rotate it, we just have to remember that little trick. If number 4 is coming forward, it's the opposite of what it looks like. So it looks R, but it's really S configuration. So if we were to redraw our molecule, so it's a little neater and we can see everything again. We end up with the configuration of R, S, S. Now we know what the stereochemistry is for all of those. So now I should be able to start assigning the stereochemistry to a stereocenter, whether it's just a tetrahedral carbon in a chain or in a ring. You should be able to correctly assign the RNS configuration. And if you need to right now, use a model to help you visualize. Start trying to see if you can think about the 3D model and the 3D molecule in your head.